Hi everyone, welcome to this course on structure analysis. This course is called as SA1 or Structure Analysis 1, where we are going to discuss the basics of structure analysis. Um, so the agenda of this meeting is as follows. First of all, introduction to myself. Then I'll briefly discuss course contents, subsequently course outcomes and objectives, and then moving to examination, assignments, grading policy, and finally textbook and references. Now, my name is Dr. Azam Khan, and I'm a PhD in structure mechanics. I am associate professor of structure engineering. I've got a 10 years industry experience and 5 years teaching experience. My research area is finite element analysis and modeling. I have worked on steel and concrete structures. Okay, my office number is 116. It's in Ski Building. My mobile number is flashed in front of you. I'm available from 9 to 5, and I maintain an open door policy. So whenever you have any sort of issue, give me a buzz. I also set out a WhatsApp group where you can always post any message or any query, and I will try to respond it as soon as possible. So I've got my WhatsApp on the mobile number, and I will ask the CR of the class to set up a WhatsApp group, include me as an administrator, and then we can communicate from there. So, okay, so this course is about an structure analysis. It's an introduction to structure analysis of determinate structure. This course will develop an ability to calculate structure deformations, support reactions, and internal forces for determinate structures. It will develop your ability to draw influence lines for a determinate structure, and it will help you to work out deflections of determinate structures. So mainly we'll be focusing on trusses, beams, and frames. The objective of this course is twofold. First of all, to understand the principle of structure analysis of determinate structures, and secondly, to analyze determinate structures under static and moving loads. Now, in front of you is displayed the course contents. First of all, the course starts with the introduction to structure analysis of determinate structures. So in the first week, we will get ourselves introduced to different type of structures, the importance of reactions in structures, and the ways to work out the reactions in structures. Beside this, we will understand the concepts of stability and how to arrange our loadings and our supports to ensure a stable structure. The second and third week will involve analysis of statically determinate structure, determinate trusses. We will use method of joints and method of sections to determine the to analyze the trusses. For in the week fourth and fifth, we will look into shear and moment diagrams for determinate frames and beams. The week 6 will be an examination week, so therefore it's left blank. The week 7, we will start deflections and use double integration method to determine the deflections of beams. On week 8, we will do deflections. We will again continue with deflections, and we will use moment area methods to solve to determine the deflection of beams. Week 9 and 10, we will discuss conjugate beam methods. Week 11 and 12, we will again we'll continue with the deflection methods, but use a unit load method to find out deflections. The week 13, we will start influence line diagrams for beams, reaction, beam shear force, and beam bending moment. Week 14, we will we will continue with the influence line diagrams, and we will we'll try to find out the maximum moments, maximum shears in the influence line diagrams, and the the practical use of influence line diagrams. So we'll try to understand these concepts. Week 15, we will try to analyze cables. Week 16 will be devoted to 3-hinge arches. And finally, on week 17, we will have an end semester exam. Now, the course outcomes and objectives, mainly this course will be focusing on problem analysis. So therefore, the program learning outcome would be problem analysis. The course learning outcomes are two, as you can see on the screen. There are two course learning outcomes. One is to analyze two-dimensional statically determinate structures under variety of imposed loading. And the second course learning objective is to be able to understand influence line diagrams and use influence line diagrams to analyze the response of structures, determinate structures. So the table can show, the table is clearly showing that the CLO, that the CLOs are mapped to PLO2, which is the problem analysis. In this course, we will have quizzes and assignments beside midterm exam and end semester exam. I'll try to take 4 to 5 quizzes, then 4 to 5 assignments. The weightage of the assignments, quizzes, midterm exam, and end semester exam is given. Assignments will carry 10% of 10% weightage, quizzes 15%, midterm exam 25%, and 50% of the marks will be devoted to end semester exam. The textbooks and references are shown on the screen. We will mainly focus on structure analysis by R.C. Hibbeler. I'll try to solve problems from R.C. Hibbeler in the class, and I will also give you class notes. Beside that, my presentations would also be available to you. So you will have the opportunity to write my notes down from the board, or you will be given some handouts also, which will summarize whatever I do on the board. And in addition to that, you will also get my slides. So there would be quite a lot of mediums for you to study from. But the important thing is that you read the book, you try to understand the book, and my notes will be a useful supplement to your book. Now let us get into structures. What is a structure? That is an important question, which I think so is appropriate for this first class of ours. A structure is a set of connected parts which support load. So imagine we have a beam, Sorry, why is this not working? So we have got a beam, and this beam is subject to some load. So the a structure is a structure consists of a component or a combination of components which supports load and which transfer the load to other points. So a structure is a medium which transfer the load to other points. That is a simplest definition of structure. So in this figure, you can see that we have got a beam which is simply supported. It is supporting a load at the middle, and it is transferring this load to the supports. So the structure is acting as a medium to transfer this load to the supports. That is our structure. In structure analysis, we must develop an understanding of the transfer of force and the and appreciation for applied loads and dimensions. So what do I mean? I mean that if we have, for example, a 30 kilonewton load applied onto a beam, and this beam, imagine, is say 3 meter and 3 meter. So first of all, we must understand what type of structure is used to transfer this load. So in this case, it is a beam. So this is a beam, and we know that beam is a horizontal member which transfer the load to the support points. Now, another thing which I said is to develop appreciation for the applied loads and the dimension of the beam. The applied load is 30 kilonewton. What do we mean by 30 kilonewton and how heavy it is? That is an important thing to appreciate. Now, in this case, we have got 30 kilonewton, so we can write it as 30,000 Newton, or we can write it as 3,000 kg. In other words, we can say this is 3 ton of load. So 3 ton of load is applied over here. By developing appreciation, I mean that what is 3 ton of load? So we have to develop a reference weight in our mind with which we can compare our applied loading, and that reference weight is helpful to see whether the applied loading makes sense or not. Obviously, we can't apply too less load or too big load that a structure is not able to bear. So for that reason, it is important to develop understanding of the applied load. So 3 tons, when someone tells me a 3 ton load, I always go and think of an ordinary car. An ordinary car, if I assume, is 1 ton. So this is equal to the weight of 3 ordinary cars which are placed over here. So that is the magnitude of the load. Someone has parked 3 cars on top of each other, and that load is aimed to be transferred to the support. That's what 3 ton mean. So it is important to appreciate that when we are talking about structures, the weights are normally in tons, or so it's not in pounds, it's not in kgs, it's normally in tons. Ton is an appropriate reference weight with which we can compare the loads and the weight of structures. Similarly, we have to develop appreciation for the dimensions. Now 3 meter. 3 meter is a dimension, or is half length of this beam. This beam is almost 6 meter long. So how much long is 3 meter or 6 meter? So we can develop a reference point, a reference length, which is say height of a single story building, or height of a room, an ordinary room. So height of an ordinary room, I know that is round about 3.3 meter. So approximately we are talking about, this is twice the height of the room, an ordinary room. So 6 meter is round about a two-story building. So this is, the length is almost equal to a two-story building. So that way we can develop an appreciation for length. We will normally be dealing with two different types of units in this course. One is the SI system, another one is US customary system or foot-pound system. So 30 kilonewton, 30 kilonewton, or say 1 kilonewton, is equal to 0.225 kips. So we can always multiply the kilonewton into, we can convert the kilonewton into kips by multiplying it with this factor. Similarly, for lengths, we know that 1 meter is approximately equal to 3.33 feet. So I think that this is a good starting point for our structure analysis course. First of all, we must know what are the different types of structures available. So we can have beams, we can have trusses, we can have frames, and so on and so forth. Then the reference weights and reference dimension, reference lengths. So this is a brief introduction to loads, and from the next class we will start with the different structures and how to determine the reactions on structures. Thank you very much.